And then moving on, we have 5 problems with 5 data mining technique. So the first problem we have is the influence of age on drug-related death cases. The data mining technique used is prediction. The second one is drug-related risks based on age classification, and the data mining technique used is classification. The third one we have frequent drug combination in overdose cases, and the data mining technique used is association rule mining. So in the background of project, we have 5 problems here. The first problem is influence of age on drug-related death cases, and the data mining technique used is prediction. The second problem is drug-related risk based on age classification, and the data mining technique used is classification. The third one we have frequent drug combination in overdose cases. The data mining technique used is association rule mining. The fourth one is identifying patterns of polydrug use among death cases, and we use clustering. The last one is detecting unusual drug death cases with anomaly detection as the data mining technique. Moving on to data preprocessing technique. In here, we check for the missing values first, because we have to clean these missing values to ensure that dataset is clean and suitable for the next preprocessing. And then since age only has 2 missing values, we will fill with median, because median is not affected by outliers, while mean is extremely sensitive to extreme values, and mode is suitable for categorical values. And then after filling the age, we will convert the age into integer. And then here we convert the drug column into binary. So all the drugs are grouped into drug column, and then we convert them to binary, where 1 means that drug is present and 0 means drug is not present. And then we will replace all the blank values or the non-values using unknown, because unknown is easier to detect and help maintain consistency and avoid error during model training. Aduh, Shibal.
In this section, we applied 4 technicals: practical, prediction, and classification, animal detection, clustering, and we use linear regression to predict the number of the gene based on age. This method is suitable because the target is continuous. It is simple and more interpret compared to complex models like Riemann forest. We use logical regression to classify case into simple more than 3 traps and complex less than 3 traps. This method is suitable for brain classification, and this is efficient. And we use LS selection forest to detect unusual case. It is efficient and works well for detection rare animals. Compared to other methods, this requires less computation. And we use k-means to group similar case. It's simple, fast, and suitable for large database. Compared to other collecting methods, it's easier to implement. So each method was chosen based on its suitable simplicity and its efficiency.
Hello, sir. My name is Sun Xingyue. My part is the third section, which is model evaluation and validation. In my part, I mainly analyze the performance of 4 models we built earlier, including prediction, classification, clustering, and anomaly detection. Because building a model is not just about getting results. We also need to make sure it actually works. So we use different metrics and also try testability to validate the models. First is the prediction model. We use linear regression to see if H can predict dog count. So R squared is almost zero, which means H cannot really explain the outcome, so this model is quite weak. Clustering. We use the k-means to see if there are any groups in the data. The result shows that the clusters are not very clear, meaning there is quite a bit of overlap. For anomaly detection, we use the isolation forest and found about 3% of cases as anomalies. Although there are few, they are actually the most interesting ones. Next is classification. We use logical regression to classify cases into simple and complexes. The accuracy is around 52%, and the F1 score is also not very high, so the model's performance is quite limited. For model selection, we choose model based on the task like regression for prediction and logical regression for classification. We also did some basic tuning, such as handling cost imbalance, and adjusting anomaly proportion. For validation, we use a trend test split to make sure the model generates well, and we use multiple metrics together. Overall, the results of four models are similar. Our evaluations are complete and results are reliable. That's all for my part.
Moving on to data visualization and interpretation. For this visualization part, there are a few techniques used for the visualization. And in the first one, we can see the track that's across each group, which is visualized using the line plot. And then here we create the age group first using pins and label. We create age group so it is easier to get insights from the result. And then here we can see the line plot visualizing drug related stats across age group. And then based on this result, we can see that the highest number of cases belong to the 26 years old under 40 years old and 41 years old under 55 years old age group. Meanwhile, the rest of the age group we can observe lower number of cases. And then the second one, we can see drug involvement by gender. On the left side, we can see the drug used by gender, but we have three variables, which is the male, female, and unknown. And then on the right side, we only have male and female. Both are the same, it's just that the left side has unknown, and on the right side, there's no unknown. And then from both of these charts, we can see that male has over 8,000 cases compared to female with only around 3,000 cases. This means that male contributes a larger part of the drug usage. And then moving on, we have the pie chart. It is similar to the previous one, but pie chart visualizes using the percentage. And here we can see that male contributes 74.2%, while female contributes 25.7%. So male consume 3 times more than female. And then next we have the most frequent drug involved in each cases. So here we can see that the highest number of cases with around 8,000 cases is fentanyl and any opioid. So this also means that most of the people in the data set, they consume these drugs. And then next we have total drugs involved in each cases. So basically this histogram visualizes the number of drugs each individual takes. And then in here we can see that the peak is around 3,000 cases with people taking 3 drugs at the same time. Oh sorry, I mean in each cases. And the next is the heat map. So this heat map basically just show the relationship between 2 drugs and whether they are related or not. And then we have clustering drug death cases. These k-means clustering are used to group drug-related death cases based on age and the number of drugs involved. So in this purple cluster is mainly for individual age 10 until 50 but with lower number of drugs involved. And then the green one is middle age from 18 to 75 years old with high drug involvement cases. And then the yellow one is for the older ages, which is from 50 until 90 with moderate number of drug involved. So from this result we can conclude that middle age, which is the green cluster, are more likely to be involved in drug-related death cases. And then lastly we have the anomaly detection using the box plot. Here we observe the number of drugs per case. So here we can see that the mean is 3, similar to the histogram before, and then the interquartile range is between 2 and 4. So the most number of cases lies between 2 under 4 drugs per cases. And then the anomaly is in this part where we have the circles at the end. So this part at the end are considered anomaly since they have different behavior from the rest of the data.